Now we are going to learn about the spectrum and network density management in 5G ultra dense network. Coming to myself Srinath, studying E section ECE section B, bearing with the rule number 21951 A04L5. Here we would like to know spectrum and network density management in 5G ultra dense network. Here coming to the introduction to spectrum and network density management in 5G ultra dense network is spectrum and network density management are crucial in 5G ultra dense network to ensure efficient in use of resources. It might be balancing spectrum or network density is plays a key role to meeting the high data demands of user in dense urban areas where effective management strategies can optimize network performances and enhance user experience also where you can see here in this diagram. You can observe here some spectrums and density waves are being produced by the macro RRH, small RRH, and wide RRH and small RRH. It being be trapulating from one sector of the position of one sector of position core network and the backhaul also. You can observe here. And coming to the spectrum allocation in 5G ultra dense network is spectrum allocation in ultra dense networks involves assigning frequencies to different network elements to avoid interferences where curating the dynamic spectrum sharing techniques enable efficient utilization of available frequencies in crowded environments, and it has been advanced spectrum management algorithms helps in operators maximize spectral efficiency and quality where the network density consideration in 5G ultra dense networks is network density refers to the number of access points or base stations deployed in a given area. That could be the higher network density in 5G ultra dense networks enables better coverages and capability, especially in urban areas wherein proper network plannings and deployment strategies are essential to manage interference and ensure quality of service. Where coming to the 5G security challenges, there are coexistence of 4G and 5G requires consistent and higher performance security, more devices and more bandwidth for hackers to utilize. Network slicing and virtualization brings new risks. Distributed edge clouds open up new attack surfaces. Manual operations are not enough anymore to stop threats. Here, coexistence of multiple networks and technologies in ultra-dense environment can lead to interference issues. It can be have a limited spectrum availability poses challenges for operators looking to deploy high capability high capacity 5G network, or can having the managing network density is a in a cost effective manner while maintaining quality of service is a complex task where interference mitigation techniques in 5G ultra dense network beamforming and massive MIMO techniques helps focus signals towards intended users and reduce interference. It means 5G has been produced into massive MIMO, millimeter waves, full duplex, machine to machine, beamform, beam forming. Beamforming and massive MIMO technologies helps focus signals towards intended users and reduce interferences. And the cognitive radio systems dynamically adapt their transition parameters to avoid interference with other networks. The coordinations between the neighboring cells and networks through advanced algorithms can mitigate interference effectively. We're coming to the spectrum sharing strategies for 5G ultra dense networks are LSA, SSA, and DSA. Where LSA is licensed shared access and SAS is spectrum accessing system. These two are enable spectrum sharing between different operations or technologies. And coming to the DSA, dynamic spectrum access allows operational use of availability frequencies to optimize spectrum utilization, where aggregation techniques combine fragmented spectrum bands to create wider challenges for higher data rates. And the network slicing for efficient spectrum and network density management. Network slicing divides a physical network into multiple virtual networks tailored to specific use cases, whereby allocating these resources on demand. Network slicing enables efficient spectrum utilization and network density management, where each network slice have its own spectrum allocation, quality of service requirement, and network architecture. We're coming to the small cell development strategies in 5G ultra dense network. Is small cell plays a critical role in increasing network capability and coveraging in dense urban areas, where HetNet deployments combining small cells with macro cells helps improve network performance and spectral efficiency, where CoMP, coordinated multipoint. It is a coordinated multipoint transmission techniques enhance small cell deployments by reducing interference and improving connectivity. And the spectrum efficiency enhancement is in 5G ultra dense network. The advanced modulation schemes like 256 QAM LDPC coding increases spectral efficiency and data uh, through output. And here, the TDD and FDD plays as optimized spectrum usage, that is time division duplexing and frequency division duplexing. Reframing and reframing techniques help operators repurpose existing frequencies for 5G services. And coming to the future trends in spectrum and network density management for 5G is digital world, human world, physical world. It might be 6G. The evolution towards 6G generation will require even more efficient spectrum and network density management techniques, where integration of satellite communication, terahertz frequencies, and dynamic spectrum sharing will shape the future of wireless networks, where it can be collaboration between the industry stakeholders, standardization bodies, and regulators will be essential to drive innovation in spectrum management. And coming to the conclusion, this conclusion states that 5G network is produced by massive MTC network operation, critical communication, enhanced mobile broadband, EVX, EV2 it been. So, spectrum and network management are critical for optimizing the performance of ultra dense network. And, has been effective spectrum allocation, interference mitigation, and network planning strategies are key to meet the growing demands of users. So that continued innovation in technologies and technologies and regulations will shape the future of spectrum and network density management in next generation wireless networks. That can be the 6G network, 6G. See here, network slicing, reconfigurable connectivity, routing migration, interworking, e-health wearables, subway stadium, vehicles automation, driving, AR, VR, train, airplane, USD hologram, and industry robot, drone game sports. This all being the place the 5G networks conclusion about the slides, and coming future generations it can be avoided by the or generated by the 6G generations, so that it can be have a